Hey everyone, it's Adam Smith from the field engineering team here, taking you through a quick video on how to install your hybrid runner on Azure and AKS. There's two main parts of this installation. The first is installing the Kubernetes infrastructure in AKS, and the next is installing the configuration for your cluster so that the pods will connect to Maia. This is also known as your Helm configuration. Firstly, we're just going to start off and set up the hybrid runner within your Maia account. I've just logged in as an administrator here. I'm going to go to the title on the left which says runners and instances. Click on runners. I'm going to click add runner, and we're setting up a Maia runner today. I'm going to give it a name, can give it a description. The cloud provider is Azure, but we've got other cloud providers available. We're going to actually pick a AKS deployment here, and you can pick either the current or the stable track. The current gets releases usually once or twice a week. The stable will get releases once every month. All releases are fully tested, it's just the release cadence which changes. In this case, I'm going to pick current to get the latest releases and click create runner. And that's the runner setup within your Maia account. But we can see that the runner data is pending. This usually means that there hasn't been any connection from a runner within your environment. In this case, it's Azure. So we need to go and install this runner. So we've got multiple tabs available here. The one we're going to look at is the deployment tab. We get a link to view the documentation here, and also we get access to the deployment library here. There is a GitHub public repository which has full Terraform templates for installing your runner on the different setups. So before we do anything, we need to download this Terraform library so we can utilize it and use the Terraform templates which are part of it. In advance of this video, I've installed the Terraform and also the GitHub CLI, and I'm using a Mac, but we can also do this on a Windows environment. We just need to have a bash or shell terminal so that we can run the different GitHub and Terraform commands. This is my terminal, so I'm firstly just going to download this specific repository. If you click on code here, you can get HTTPS, SSH, or GitHub CLI commands. In this case, because I've installed the GitHub CLI, I can just copy this command. This will clone the deployment library so that I can use it later. I'm going to use Visual Studio Code, but you can use any editing tool which you're familiar with. So I'm going to open up Visual Studio Code. I'm going to navigate to the repository which we've just downloaded, and now I've got access to the different folders as part of the deployment library. If we go back over to the GitHub repository, we've also got a very simple README which we can follow to install the different parts of the Terraform library. The first step to do this is we actually need to install the Kubernetes infrastructure within Azure, and we're going to use AKS for this. So I'm going to go to section 4, and if we scroll down here, it gives us some different CLIs which are useful to have to installed. So in advance, I've got Terraform CLI, Azure CLI, and the kubectl one, as well as the GitHub one already installed. Now, if I just scroll down, we can go to the relevant part. So we've got some instructions here, and this is for installing the Helm configuration. But firstly, what I need to do is actually set up the Kubernetes infrastructure. So I'm going to go and scroll down here to the part which says Azure AKS deployment. I've already cloned the repository and I'm now currently in the root of this. It's asking me to CD to the Azure AKS folder. So if I just go to a new terminal here, we can see it's in the root of the deployment library. I'm going to CD to that directory. It's now talking to me about copying the example Terraform TFVars example file to this new one called Terraform TFVars. And also in the left hand side, I'm now going to navigate to this to see if there's any of the configuration which I need to change. So we're going to go to Runner, Azure AKS. We see it's got a new file here called Terraform TFRs, which was a copy of the example one. And we've got some properties which we just need to fill in here. So I'm just going to go and get the subscription ID and the tenant ID. And also I'm going to change the location to the region I'm using, as well as finding out the resource group which I want to use. There's obviously lots of different ways you can get your subscription ID, your tenant ID, and your region and resource group. I'm just logged into the Azure portal here, so I've just searched for subscriptions and I can get the subscription ID here. My tenant ID, this is usually found out in Entra ID. You can also find it out if you go over to click on this cog here, and I've got a couple of different subscriptions, but it's the directory ID. You can also confirm this by going to Entra ID as well. And what we can see here, we've got the same tenant ID, which is here. See, this matches the directory ID here. The resource group I'm going to use is, if I just go to resource groups, and I've just got one for the UK West region. So we can see that the subscription ID here also matches the one I'm using here. And in D3, I'm going to use the location of West UK, and my resource group is, this is my name of my resource group. Within Azure also, getting the JSON view often kind of helps you get more details about particular regions. So here it says UK West, so I can tell that I've put it in slightly incorrectly. And then I'm just going to keep all the defaults here. I'm not going to change the name. We do have different sizes which you can use, but I'm just going to use the standard of a D4S V4. I'm going to set the cluster not to be private just to make it a little bit easier for me to connect and configure this. But if you were rolling this out in production, you may want to set this as true. Now for authorized IPs, so I'm whitelisted and I can actually connect to the cluster, I will need to change this so it's the IP address of my office I'm using. Now I have the IP address of my network I'm using. This will be automatically whitelisted, so when I'm configuring the Helm configuration later, I'll be able to connect to the AKS cluster. It's best practice to enable a NAT gateway. We're going to use workload identity enabled as true, and that's it. So the next steps are, if we go back to our documentation, we can see it's giving us the commands to now initialize the Terraform, create a Terraform plan and apply. I'm just going to initialize the Terraform now. Do a Terraform plan, and the last command is just to do a Terraform apply. This deploys the AKS cluster within your Azure account. You may get an error or a warning saying this argument is depreciated. You can just ignore that, it will still work fine. So the Terraform deployment takes around 10 minutes. So I'm just going to fast forward to the completion of the AKS cluster within Azure. When your AKS cluster has finished being deployed, you'll get output which is similar to this. A couple of things to point out. You will need to run this command so that when you're doing the Helm configuration, it knows which cluster to apply that Helm configuration to. So I'm just going to copy this command here and just paste it now into the terminal. The next thing you need to record is just make sure you note down what the workload identity client ID is. You'll need this later in the Helm configuration. But within Azure, if you go over to your resource group and search for the name you defined earlier, you can see all the different resources which have been created. In this case, we've got the Kubernetes service, We've got the log analytics workspace for monitoring, a NAT gateway, the key vault, a security group, and also the workload identity, which is going to be very useful for later. I'm just going to note down that name as well here. Now back to the README. If we go to the first section on Kubernetes deployment, we can see that there are some additional commands which you need to run. So I'm just going to copy these two here because we've already cloned the repo. This is also can be used if you already have a Kubernetes environment already deployed. I'm just going to run those two commands to create the Matillion and the Prometheus namespaces. Run this to install the monitoring. This one you just have to pick which one is relevant for your environment. In our case, we just pick the one which is relevant for Azure. This is for AKS. Now I do need to make sure I'm in the correct directory to do this. So I have to be in the main deployment library directory. I can just run that now. And what this will do now is it will create me a my-values.yaml file, which will be in this directory. So I can open this one here now. And here we will see that we have different configuration based on the Azure AKS setup for my runner. Not many things you need to change here, but some important ones to call out is that we need to get the OAuth client ID and client secret. This will be stored on the runner. So we can go over to back to our runner here, get the credentials, click reveal, copy the client ID, come back to your my values YAML file. We'll go back over here as well, get the secret. We can keep the service count and role on the same. We don't need to change them. The account ID, so this is back over to your deployment parameters here. We can just copy them across here. My agent ID. Your region is probably in the US. For me, it is in the EU. There is some additional properties you can set, such as proxy configuration, certificate location, as well as if you've got additional Python libraries you want to load onto your pods or external driver locations as well. I'm just going to keep these the same today. Now, the only additional configuration you do need to make is if you scroll down here, you'll have one for your subscription ID. So I'm just going to get my subscription ID here, but you may have that from previous setup. So we've got that a value that actually will match what you defined earlier here, as well as your runner workload identity, very important. We actually took that down as a note previously. If you do need to get it again, though, you can run this command here. There are additional properties you can configure, but if you just follow this standard installation, just using the workload identity, the environment should be set up correctly. You can also look at the runner size. There's documentation which allows you to decide what runner size you can pick depending on workload. In the Matillion Maia documentation, you can get more information on the runner sizes. For today, though, we're just going to use a small runner size, and obviously you can change this later depending on the size of your Kubernetes cluster. So let's go back to the README file. Then we have one final command to run to install this Helm configuration within your Matillion hybrid runner, and this will then deploy the appropriate pods, which will then connect to Maia. Once that's run, as it runs successfully, you should get output similar to the above. We can also list the Kubernetes pods. This may just take a couple of minutes while these containers are first being created, but when you first run this, you will see the status container creating and the age 15 seconds. Let's just fast forward to where the pods are finished creating. Now that the pods are all at the running status and have been up for several minutes, we can go back to Maia to check whether they've actually connected. So we can just click on runners. You will need to either switch back to this screen, the runners screen, or refresh the screen here, or it will say pending. And now we can see that the runner has been successfully installed and is connecting to Maia, so it's ready for running any particular pipelines. If you want to add your Snowflake key to your new key vault you've created, you will have to do this via the Azure command line, CLI. If you do this, try and do this here, it will cut off part of the key. So if you go back over to your Cloud Shell, make sure that you've got the vault name correctly defined, and then you should get the output of the key. If I go back over to my key vault here, we will see that the key is correctly displayed. Once you're inside your project, you can go and add the environment. I'm making sure I select the correct runner. You can use owner or contributor access as the default environment access. I'm just going to pick owner. Now I need to just paste my Snowflake environment. I'm going to put my username in. It uses the workload identity of your key vault to access the vault. Here I've noticed that the vault name is incorrectly defined. In my example here, I've actually noticed that the key vault I configured was incorrect. So if you make any mistakes and you need to change anything within your Helm values, you can come over to here and you can make your changes. In this case, I've realized that the default key vault, I had left the original values. If you want to make any changes to this configuration, you can then use this command, similar to what we used before, but change the Helm install to Helm upgrade. Run this command, and what will happen is it will redeploy the pods with the new configuration. So I'm going to go back to my environment configuration here, and now I've got the correct vault name. I can see the private key which we've defined, and then I can continue to finish off my environment configuration within Maia. That's the end of the installation and configuration video on how to install your Azure hybrid runner for Maia. If you have any questions or queries, feel free to reach out via the support portal. There you'll find lots of different knowledge base articles, links to documentation, an interactive AI support agent. You can ask questions and get answers straight away on a whole wide range of different topics. If you need further help, feel free to raise a support case on the support portal as well. Thanks so much for your time. Hope you enjoyed the video.